Okay, we skipped over this part, but I went in and entered all this data. I'm going to jump back to the Oracle interface and just demonstrate that it's been there. You can see the last SQL statement I ran. So point of history here, and so you can see all the various things I've entered. I'll go back to select star from book, which is something I ran before when there was just one record in the table. I want it right now, and you can see that I have in fact entered all three of those rows that we looked at. So let's see what's in friend. As you might expect, those are the three rows we were looking at previously in the video, and I'll look at borrows as well, just to be complete. Boom. And there's three borrowing records, and that matches the specification you saw before. I have a friend, in each case, paired up with a specific book that they have borrowed, the date on which the loan started, and the date on which the book was returned. Only one of these books has been returned so far. The other two are presumably outstanding. So let's go back to this concept of querying. We saw that select star from the name of some table shows you all the records in the table, but we can do some more interesting things than that. I'll show you a somewhat more complex statement. All statements that read data out of the database are going to be select statements, but some of them can be more elaborate than others. In this case, I'm doing what's called a join, where I'm taking data from multiple tables at the same time. I won't belabor the syntax here because this is something we're going to cover kind of around week 7 and 8 of the course. But you can see this idea that I'm selecting from multiple books. You can see books in here, borrows is in here, even friend makes its way in here, and I'm doing some sort of connection. That's what the join keyword does. I'm basically saying with these on clauses, I want the values of these two columns to match. So in cases where the book table ISBN column is equal to the value in the book column of the borrows table, smush that data together. And again, I won't belabor how SQL statements are constructed. We'll spend a lot of time on that this term. But suffice it to say, for our purposes right now, know that you can combine data from various tables with these SQL language constructs of the select statement. You're not just limited to select star from a particular table and show me all the things in that table. And I can also limit it other ways. I can say, in this case, only show me these conjunctions of records where all these things match up between book and friend and borrows, and also where in borrows that end date is null. So with this, I'm basically looking for things that have not been returned yet. I'm going to copy that statement, and I'm going to run it from Oracle. And from that, you might expect that I'm going to end up with these books borrowed by these friends. Now, as you'll notice from the syntax here, I'm selecting the last name, the title of the book, and the start date. So it's what comes across is going to look a little bit different than what you see down here, but I should get a somewhat friendly report that tells me who has what book. It's going to have things I recognize as opposed to the friend ID and the ISBN identifier. It's going to have friend last name and the title. And what was our third thing here? And also the date on which the loan was started, or the date on which the book was borrowed. So I'm going to paste that in here and run it. Boom. And as we expected, those two titles came back, War and Peace and the Oracle Complete Reference. Those were the ones that do not have any end dates associated with them. Essentially, they have been borrowed, but they are still on loan. You can see the 15th and the 17th, the 15th and the 17th. The book that was returned on the 19th is not showing up, and again, that's because of this, where the end date is null clause. Null basically means blank or the absence of a value, and so that particular record was excluded by the way the SQL was written. So now you can see how we create tables on the basis of a certain design. We can stuff data into the tables, read that data out, etc. The last thing I want to show you is the concept of views and how they can implement so-called external schemas that we talked about in week 1 of the course. So in the first week of the course, we had talked about the concept of an external schema. You could think of an external schema as basically a window of sorts into the table designs that comprise your database, and it's typically going to show a slice of that data, a slice of those tables that caters to a particular user community or a particular purpose. It may join tables together, may filter out certain rows, whatever the case may be, but it's a little window into the overall database that's kind of associated with a dedicated purpose. As I said, be that a particular application that needs to use it, a community of stakeholders, a certain job role, etc. By putting in external schemas, we have a sort of a layer of abstraction on top of our data. And as we discussed in week one of the benefits of that is we can change things flexibly under the covers, and consumers and users that may use our external schemas, they don't necessarily need to see anything different. The things could be changing under the covers, we could be fiddling with our table designs, and the view or the picture that's presented by the so-called external schema could remain the same. One way that we implement the external schema concept in database systems is to use something called a view. A view is basically a query, just like the select query up here, but we store it in the database as an object that can be referenced. It's not just a block of code that I paste into some editor or execute from some application. It's something that gets saved in the database and I give it a name. In this case, I'm giving a view the name onLoan, and I'm taking the query that we ran previously and applying it there. So this view is going to show me things that are currently on loan and have not yet been returned. And you can see it just follows the same logic as the other query. So I'm going to put in this statement to create the view. It was successful. Now, what's nice here is, again, I've created this virtual table whose data kind of gets pulled in on the fly whenever it gets referenced, but I can treat it just like any other table. So I can, well, not all the time, but let's say in terms of reading data out of it, I can just say select star from on loan the same way that I said select star from book. Now if I run that guy, I messed something up here. Oh, that's a colon. Shouldn't have done that. There we go. And you can see that same data came back that I saw when I ran this somewhat more complicated query down here, blah, 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 blah. Now that stuff is all baked into the loan, if you will. Excuse me, is baked into the on loan view, and no one needs to see all this nasty complexity and the joins and the logic about the end date being null, etc. All they need to know is that semantically, excuse me, went to the wrong spot, the meaning of this particular view on loan, this virtual table, is show me stuff that's on loan, and it just comes back. I just say select star, show me everything that's in on loan, and the data set comes back. I don't have to worry at all about the underlying business logic. Now, here's what gets interesting in terms of external schemas. What if I decide that I want to change the way I record data in my database? Previously, I had said that for things that are on loan, I'm going to know they're on loan if the so-called end date of the borrowing is null. And that sounds fairly reasonable. But what if we said, it would be really desirable if we could establish a projected end date or something like that, almost like a due date. Now, rather than just leaving this open-ended borrowing, maybe in my database I'd like to establish the date the borrowing starts and a date that it's supposed to end. If I were to do that, that might be useful, but that would kind of break the logic I had in my view here, where I'm saying, well, when things are on loan, I can tell they're out there if that end date is null. If I decide that I want to start populating that end date column in any case, then that kind of breaks my logic. Seeing an end date of null or blank is no longer going to be the way that I figure out whether or not a book is still supposed to be on loan or not. So just for fun, we are going to update a couple of records in borrows, and we're going to make sure that everything has an end date. I'm going to run a so-called update statement. Insert stuffs data into a table, select reads it back out. Update takes an existing record and changes some of the values in it. And there's also a delete statement that does, as you might expect, takes rows out, but we're not going to look at that today. So I'm going to run a statement, and I'm going to supply an end date for a borrowing record that previously did not have one. Then I'm going to go and do the same thing for the other borrowing record. After I run this guy, I'll do a quick select star from borrows. Again, that just shows me all of the records in borrows. as you guys may have inferred, case does not matter in SQL, at least with the keywords there. I've done uppercase and lowercase, etc. So I'm doing select star from borrows, boom, and you can see now that everything has an end date. I'll remind you that I am writing this in the wee hours of the morning on Thursday, June 23rd, 2011. So you can see that this particular item, which has already been returned, is obviously in the past. These future dates up here represent the expectation or the due date that these items borrowed on these particular start dates will be returned by the 24th of June. Given that I've made this change, as I said before, this whole idea of end date is null is the way I figure out what's on loan. It's just broken. Now there is nothing with an end date of null, even things that really are on loan. And if I do select star from on loan, I'm not going to get any records back. That's not good. So changing something, these values in my database, fiddling with the tables and how they're managed, has caused an undesirable ripple effect. But here's the virtue of an external schema. By putting in this layer of abstraction there, by putting this view in there, I've kind of put a layer of indirection between consumers of the data and what's actually going on in the tables. So if people were reaching directly into the tables with a query like this guy, up here, the unvarnished one that was under the covers of our view, but if people and applications were issuing this query directly, we would have just broken what they were doing. However, if they're pulling from the on loan view, a nice thing we can do is just change the definition of the view. And so here, I've changed my query slightly. I'm saying that on loan is going to look pretty much the same. It's going to return last name, title, and start date, but I've fiddled with this logic here. Rather than saying where end date is null, now that I'm always populating the end date, I'm going to say, well, future stuff, as we saw here. Let's see if I can pull this guy up again. It goes back. Future stuff is going to have an end date that is greater than today. In Oracle, sysdate is kind of a dynamic keyword that means the current date. So in this particular query, I'm saying rather than looking for things where the end date is null, I'm going to look for things where the end date is greater than today. And those are the things that should still be on loan, so to speak. So something that was returned on the 19th is not going to show up on here, but something that has a target date in the future, like those two records for the 24th, that should get captured in here. Now I realize we could problematize that logic and talk about scenarios in which maybe that's not the best way to encode or represent these things, but just for the sake of argument, let's say that will work for our situation, because our main goal here is to just demonstrate the idea of an external schema and the flexibility it gives to us. So I'm going to replace the old definition of my on loan view with this new one that is conscious of the changes in how I'm going to manage and encode my data. I run this guy, my on loan view gets recreated, and now when I do select star from on loan, it shows me the same old thing it used to do. It shows me the sort of data I want it to return, even though I've totally fiddled with the values and how the data is being stored and managed in that end date column, because I had this layer of abstraction, this so-called external schema in place via the view. Now I can fiddle with the implementation of the view and still show users and consuming applications the data they want to. All they have to do is their standard select star from on loan, the same thing they always did. And I manage the complexity of how to make on loan show the right things inside the database where they can't see. So they don't have to bother to change their code. They're none the wiser of the way I've changed my internal management of that end date column.